All right, here. So for this problem here, the information we need to take out of here are the percentages for countries C and D, the sample size for countries C and D, which is listed in the problem, and then you have to calculate the number from each sample that corresponds to that percentage. So just for country C, for example, 46% of 1,050 would be 483. Multiply those together and get the actual number from each sample. Do that um, for both of your samples here. Now, what we are trying to do is find the standardized test statistic. The bottom part of the calculation is where I'm going to start. That's the most lengthy and kind of most complex. You see, we need those pieces of information. We need the sample sizes, the N1 and N2, and the number from each sample is X1 and X2. And P hat is, or sorry, P with that line over the top of it, that's the main thing we actually need. That's the biggest calculation we need to do here. And it looks like we're adding X1 plus X2 over N1 plus N2. And the easiest way to think about that is we are just combining both samples all the way together and finding what is the proportion then of just everything combined together. So for example, these are our two sample sizes. If we added those together, we'd have this many total people down here. I'm highlighting it in blue. And the number in favor from each country separately, if we added those together, it'd be this many people in favor. So this combined, everybody combined, if we actually did that, 915 out of the 2,130 people would be this percentage out of everybody combined. That's what that first part of the calculation on bottom is for P with these X's and N's added. And Q is just 1 minus that. Q and P always add up to 1. So once you find P, just do 1 minus that to get Q. And then the last part is of this giant square root on bottom is 1 over the first sample size plus 1 over the second sample size. And so that's what I'm doing here. I like to do these three pieces separately. So just 1 over the first sample size plus 1 over the second sample size, you get your solution. The bottom is the square root of those three numbers multiplied together. So I'm typing square root of those, P times Q times 1 over each sample size. You get your result. That is the bottom part of your calculation. On top, this second part on top, we're always assuming it's 0. The actual proportions we're assuming for the populations, they are actually equal. That's kind of what we're testing is, are they different? Are they not equal? So if we assume they equal, do we have evidence to prove that they're not? So P1 minus P2 is 0. So because if they were equal and you subtract two equal numbers, you get 0. So all we really are doing on top is subtracting the two sample proportions, P1 hat minus P2 hat. So the top's pretty simple. It's going to be these two sample proportions subtracted, 46 minus 40. That is the test statistic, not the standardized one, but those two subtracted is the test statistic. And then to standardize it, we divide by that square root that we just calculated. And that's all I'm doing here. Those two proportions subtracted on top, divided by that complicated square root. That is your standardized test statistic. If you round it, that's what we're getting here. Now the p-value is just using the correct formula here in Excel. And let me go ahead and type that out over here. It's norm.s.distribution, and it's the probability of getting a value less than or to the left of that test statistic that we got. So we always type in true here, and Excel is always giving us a left-hand less than probability here. And so it's 99% of the time you're going to get a test statistic that is less than or less than 2.79 away from the mean. So this is to the right of the mean. It's greater than the mean because it's positive, and it's very likely to get something there or less than. But our question was not a less than question, but a greater than question. What's the chances of getting something even further away from the mean, even greater than this test statistic? And so you just do 1 minus that answer. And that's what I have here for the p-value, 1 minus using that formula, you get the left hand, but we're less than, we're doing a greater than, so 1 minus that. This is the probability of getting the test statistic like the one we did, or even further greater than the mean. And it's a very low p-value, very close to 0. And so since it's a very low probability to have something that far away from the mean, we're going to reject our null. We're going to reject our assumption that the two countries are equal. Just from percentages from the samples, country C appears to be larger. 46 is larger than 40. And now we have concrete evidence. Our p-value is less than alpha. It's less than 0.7. So we're definitely going to reject the assumption that the two countries have equal proportions in support of the alternative hypothesis.